Hi there. Today I want to talk about our first chapter in grade 10 for additional mathematics. And we're going to be covering the uh, simultaneous equations. That is how we are going to solve simultaneous equations. So we're going to jump into um, the aspects of solving simultaneous equations immediately. The first thing, now remember this is grade 10 at maths, and we're looking at simultaneous equations. Sorry. So basically when we solve simultaneous equations, we're going to have to solve two equations at the same time. So we have an example in the book here where it says y minus x is equal to 3, and then we have xy is equal to 10. So how are we going to go about and solve an equation like this? Very easy. And so I'm going to call this equation 1 and this one equation 2. Now, as can be seen, one of the equation is a straight line. Let me just put L over here. The second one, xy is equal to 10, is a curve. So let me just put C over here. How do I know it's a curve? Because if I say xy is equal to 10, it means that y is equal to 10 over x. And we've done y is equal to 1 over x, which is basically a hyperbola. So we're not going to be dealing with the sketching of the graphs of those functions, but we're going to try and solve them simultaneously. Now it's up to us what we can do. We can either take equation 1 or we can equation 2. I'd rather go for equation 1 because the line is a lot easier. So if I take equation 1 and I say y is equal to 3, and I'll send the x on the other side, becomes x plus 3. So now I can substitute. So the idea is to use substitution to be able to solve simultaneous equations over here. So we're going to be using substitution. So replacing this in equation 2 now. So what we're going to do is we're going to substitute y is equal to x plus 3 in equation 2. We're given that equation 2 is xy is equal to 10. So x times y, and y was found to be x plus 3, is equal to 10. So we can expand this. We have x squared plus 3x, and the 10 can come on this side, becomes minus 10 is equal to 0. So immediately we can solve this quadratic equation. Now, to be able to solve a quadratic equation, you open two brackets. Those are the two factors. So you get x and x. So we're going to be looking at the product and the sum of those values over here. Now, this is basically the product. So for me to be able to get 10, I can either say 1 times 10, or I can say 2 times 5. Immediately I know this is not good because 1 plus 10 is 11, 10 minus 1 is 9, and nothing appears to be over here, 3. So the sum of those two numbers should actually be equal to 3. So how can I make this sum is equal to 3? Now, if I say 5 minus 2, I'm going to get 3. So basically what I'm saying is one of them is 5, one of them is minus 2. So 5 and minus 2 seems to work out. So I'm going to say then minus 2 plus 5. And so if x minus 2 is equal to 0 and x plus 5 is equal to 0, we can clearly say that x is equal to 2 and x is equal to negative 5. So I've got two values, a pair of values for x. And now those two values of x will give me two values of y. When I substitute these values of x into y over here. Now remember we had y is equal to x plus 3. So when, first thing, x is equal to 2, so we're going to get y is equal to 2 plus 3, which is then 5. So for x is equal to 2, I've got y is equal to 5. So this is 2 and then 5. So x is equal to 2 and then y is equal to 5. Those are my first solutions. The second one is -2. So I'm going to put x as -2 over here. So when x is equal to -2, this was when x is equal to, 2, and now x equal to negative, I would say -5 rather. Okay, so -5 because x is -5 actually. So then y is going to be equal to -5 plus the 3. -5 plus 3 is actually -2. Right, so for x equal to -5, I got y is equal to -2. That's my second solution to this problem. But they go further in the book. What do they say? Perhaps they want something else. Another question coming up with the same question here. Hence, state the coordinates of the points where the line y is equal to minus x is equal to 3 intersects the curve xy is equal to 10. So it seems to me now this is a line, like I said before, So the line may be going like this, perhaps, So it's going to intersect the curve at 2 points over here. And like I said, we're not dealing with the sketching of the curve over here. So we want the coordinates of those points of intersection of the line with the curve. So it's quite easy. We just need to state. So this is part A of the question. Now we're dealing with part B of the question. So coordinates of the points of intersection are, first of all, I've got 2 and 5, and there's no strict order. So this could come first or second. And then I've got -5 and -2. So those are the two coordinates of the points of intersection. So this is how easy it is to solve simultaneous equation by substitution method most of the time, because we're not going to be using elimination method. Elimination method is only used when you have two linear equations and both of them are straight lines. But here one is a curve and one is a straight line. For ADMATS, 99.9% the equations would be a curve and a line. And later on maybe trigonometric function or logarithmic function. Take care. I hope you've been able to make the most out of it. This is the first chapter that you're going to be doing for grade 10. All right, bye-bye.